we find the equation of a line through 7, 4 with a slope of 2.5. We do this by sketching a line through the point and putting a point xy on that line. Now, the slope of the fundamental triangle that we get here between the 2 points, rise is going to be y minus 4, y coordinate minus y coordinate, the run x minus 7. So that the slope is rise over run, which is y minus 4 over x minus 7. It follows then that since the slope is 2.5 and the slope is y minus 4 over x minus 7, it follows that if xy is on the line, this slope has to match this slope. This slope has to match this slope. And this is the equation of the line. Now, if we solve that equation for y, we get, and you can verify this, you multiply both sides by x minus 7 and do the obvious things. You have y equals 2.5x minus 13.5, and this is the slope-intercept form of the line. This is the slope. The slope will be the coefficient of x. And if you let x equal 0, then you get a point on the y-axis, because the y-axis consists of points where x equals 0. And the result is going to be the y-coordinate of the point where the line meets the x-axis, in this case negative 13.5, and we call that the y-intercept. So this is called the slope-intercept form because you can read the slope here, the y-intercept here. Now, if we want to find a line through the points 9, 5 and 13, negative 2, we draw a couple of points that represent the 2 points that we're looking at, and we find the rise to be, well, 5 minus negative 2. The difference of the y-coordinates is negative 7. And 9 minus 13 is 4. Sorry, wait a minute. No, I'm getting that backwards. Negative 2 minus 5 is negative 7, and 13 minus 9 is 4. So the rise is negative 7 and the run is 4, assuming we are going from this point to this point. So if we're going from here down to here, if we're following this path along the legs of the triangle, then our rise and run are negative 7 and 4 respectively. Now if we have a point xy out here that's also on the line, well, the slope between 13, negative 2 and xy is difference of the y-coordinates. Y minus negative 2 is y plus 2. X minus 13 is x minus 13. So we set the equation, or we set the expression for the slope of this triangle equal to the expression for the slope of this triangle. Since if xy is on this line, these two slopes have to be equal. So we're setting slope equal to slope. Slope here is y plus 2 divided by x minus 13. The slope here is negative 7 over 4. So here's our slope equals slope equation. Now we can easily multiply both sides by x minus 13 and then subtract y from both sides to solve for y, and we would get the slope-intercept form of this line. But this is a perfectly good equation of the line. We can rearrange it any way we choose, any way that fits the situation. We then proceed to the slope, the equation of the line through x1, y1 with a slope of m. We put a point xy on our line. We write down the rise and the run of the basic triangle. Y-coordinate minus y-coordinate is y minus y1. X-coordinate minus x-coordinate is x minus x1. And we do this divided by this, and that's going to be equal to m, which is our slope. So setting again the slope of this triangle equal to the given slope of the line. Slope is m, slope is y minus y1 over x minus x1, so that y minus y1 over x minus x1 equals m. Now we rearrange this, multiplying both sides by x minus x1, we get y minus y1 equals m times quantity x minus x1. And this is one of your formulas in the book. This is the formula for a straight line through point x1, y1 having slope m. The point slope form is the standard terminology for that graph. We do the same thing down here with a graph through 2 points, x1, y1 and x2, y2. So here's our x1, y1 point, here's x2, y2. We draw the line, we put the point xy, and what we do here is pretty much identical to what we did up here. We're just going to use symbols where we had numbers before. We construct this triangle. Clearly, these rise from this point to this point is y2 minus y1. The run from this point to this point is x2 minus x1. So the slope is y2 minus y1 over x2 minus x1. So there's our slope. Now we're going to do a slope equals slope, much like we did here. The slope of this smaller triangle would be, we're moving from x2, y2 to xy, y minus y2 for the rise, x minus x2 for the run. So the slope is y minus y2 over x minus x2. This slope is equal to this slope. The slope of this triangle is equal to the slope of this triangle if the two triangles have the same slope, which they must if this really is a straight line. Then we can rearrange this. We can multiply through by x minus x2. We get y minus y2 equals y2 minus y1 over x2 minus a big smudge. That's x1. And that's multiplied then by this denominator x minus x2. That's the form in the book, sort of. Okay, it's sort of the form in the book. The form in the book actually would correspond to having constructed the triangle from x1, y1 to xy, which we can do and we will do in a second. So that had we constructed that triangle, or had we let this point be x2, y2, and this one x1, y1, because it really doesn't matter which is which, we would have gotten a y1 here and an x1 here, instead of a y2 and x2. It doesn't matter which point you use as your first point and your second point. You're going to get the same equation. So this equation is perfectly valid. It's identical to this equation, which we'll talk about here in just a second. It's not identical to the equation, but it gives you the identical result. If you use the same 2 points here, or use them with this formula, doesn't matter whether it's this formula or this formula, you get the same equation. Okay, so how do we get this one? Well, we just construct a triangle from x1, y1 up to xy. Now I've done that kind of in blue here. The rise is y minus y1, the run is x minus x1, so the slope is y minus y1 over x minus x1. And that's going to be equal to the slope of our triangle from x1, y1 to x2, y2, and that's still exactly what it was, y2 minus y1 divided by x2 minus x1. If we then multiply through by x minus x1, we get y minus y1 equals y2 minus y1 over x2 minus x1 multiplied by the quantity x minus x1. And that's the way it's almost always written in a textbook when you do the 2 point, the formula for the 2 point form of the line. Now, you can get by with those formulas, but if you remember how to sketch these pictures, you never need the formula, so you never have to worry about whether you've got the formula right. You can always rederive the formula, and it only takes a couple of minutes to do that once you understand how these formulas are constructed based on these fairly obvious pictures. The next video is kind of redundant with what we did here, but not completely so. So take a look and see what you think. But everything is here, and of course this just repeats the video that was posted at the very beginning of the document.